Hello, my dear friends. I'm making this lecture for electric drive subject in electrical engineering, and my name is Shailendra Kumar Gupta, Assistant Professor, Government Engineering College, Jhalawar. So I'll make this video at just to introduce the subject. Uh, Let us just go on. Okay. So let me just provide the heading: Introduction to Electric. So, why this subject? Actually, modern day applications such as electric propulsions, pump, fan compressors, robotics, industries such as steel, paper mills, they all are running at variable speeds. They require the motor to run at variable speed. By running the motor at variable speed, um, there is a direct advantage of increased efficiency of the motor. There is a increase of 15 to 27% of the efficiency of the motor. So quite a bit of profit is involved in running these machine at variable speed. So the subject has become important for industrial science, and the component of this uh, is the first component is electrical machine, the motor which we are using. Second is power converters. Third is the load. And the fourth one is the controller. Okay, so these are four component of electric drives. So let us discuss one by one. So first, electric drives is the electrical machine. This consists DC machine and AC machine. Also, there are some modern machines which are coming into place, like permanent magnet uh, machines, reluctance machine. These machines are also being increasingly used in industries. So these are the machines which we have to use. Second is the power converter. Power converter. So what are the power converters? These are basically you can use rectifiers, or you can use choppers, the DC to DC converters. Next, inverters is inverters, no, or cycloconverter. These are basically the type of power converters uh, which we use in electric drives. And the role of these power converter is to vary the voltage and current that is being supplied to our machine. So actually what happens, So we have got a power converter, let us say PC. The supply comes to this power converter, and which is fed to our motor. This motor is mechanically coupled to a load. Okay, so these power converters controls the basically the speed and torque of this motor, so that the load and the torque and speed, omega is the rotary speed, this could be controlled. So why to control your torque and omega of the motor? So this is a very very simple reason is behind that, is that the torque speed characteristic of this motor is not same to this as to this load. Like let us say an induction motor. So we all know that an induction motor has a torque speed characteristic of like this. So here it is the synchronous speed. So and the machine runs in this operating region. This is the operating region of the machine. Now I want to run a load using this motor. So I have to see that what is the load characteristic of the how the torque of the load changes as per the its speed. So let us say that the torque of the load do not change as per its rotation speed. So let us say here it is. This is load characteristic. This is load and this is motor. So now just see, we have got one operating point here. The at this point A, the supplied torque by the motor is equal to the load torque at a particular speed. Before this speed, the load torque supplied by the motor is higher than the load, and after this speed, the load torque of the motor torque is lower than this load. So it will not be able to. It is not matching in a sense. It the if this motor needs to run this load, it has to operate at this A point, where the torque of the load is equal to the motor torque. Let us say that we want to run this motor at some other operating point, at this operating point, at this speed. Let us say omega operating speed at W naught. We need to run the load, but here the characteristic is not matching. So what will happen? So this power converter will change the frequency of this motor such that the now the new motor induction motor torque will be like this. At this is at different frequency, mind you. Now this will be your new synchronous speed. Okay, now here you can see that at omega naught, load torque is matching the motor torque. And what we have done, we have just controlled the supply frequency. Here the supply frequency has been changed as per the motor torque, motor to shift the motor load characteristics such that the motor, so to shift the motor characteristics such that it matches to the load. This is exactly what the what a uh, what a electric drive means. We just need to match the motor torque with the load torque. For this, there will be many sensors will be needed, such as the speed sensors, the torque sensors, which will be fed back uh, to our controller, to our power converter through a controller, and this whole system works in coherence. So the complete system can be drawn as like this. So there is a motor which is running a load. Okay, this is load, this is motor. So this will be supplied by a power converter. The voltage and current could be sensed and fed back to this power converter, as well as the speed and the torque. So the torque will be sensed, the speed of the motor has to be sensed, the voltage has to be sensed, and the current has to be sensed. And the supply will be a three phase. It could be three phase AC or it could be a DC supply. So after sensing all these quantities, the controller will give necessary pulses to power converter, and power converter will uh, be able to regulate the voltage, current and frequency of the motor such that the motor characteristic matches with the load characteristic. So this is all for this lecture. Thank you.